There are many types of cement. In this video, we will aim to clarify what these different types are. So an outline of what I'll be describing to you in this video, we'll be basing the main topics around AS3972, that's the Australian standards, and this is the standard that specifies the various types of cement. We have the general purpose cement that we'll be talking about, and that's the most common type, and we have some special purpose cements, and then finally we'll be talking about green cement and the performance parameters that are associated with all of these cement types. So let's start by looking at the types of cement. AS3972 gives us the outline in terms of the cement types that are available. In Australia, we've got general purpose, and that's the most common type, and then we have special purpose. Special purpose cement, you can think of these cement as being of a specific purpose. An example would be, for instance, if you require the cement to achieve high early strength. All of these cement types that we will be discussing, they need to comply with several performance parameters, and these parameters I'll be talking about towards the end of the video. So let's have a look at general purpose cement. Now for type GP, that's a short notation for general purpose, the standards specify that you can have minor additional constituents, and these are inorganic materials. The maximum amount that you can have in your type GP mix is 5% of the total mass. So in addition to these minor additional constituents, and these are inorganic materials, you can have other materials that can be added, and these include fly ash, slag and limestone. So when you combine fly ash, slag, limestone and the minor additional constituents, it should be a maximum of 7.5% of the total mass, and then the remainder would be composed of your Portland cement. The second type is type GL, that's general purpose limestone. Again, similar to type GP, we have minor additional constituents at 5%, but this time you have to add limestone. And when you combine limestone and the minor additional constituents, the maximum limit that you can reach is 20% of the total mass. So you have to have between 8 to 20%, and that is limestone plus the minor additional constituents, and then the remainder would be formed from the Portland cement to get your type GL cement. And then the third general purpose cement type is type GB, and that's the blended cement. It's composed of type GP, but this time we add SCMs. These are supplementary cementitious materials. Supplementary cementitious materials are byproducts of other materials. So for example, you have fly ash, that's an SCM, another SCM is slag, and the third SCM is silica. Now you notice that the compositions are a bit different to the other two types. So over here we have the fly ash and the slag is more than 7.5%. Whereas for the silica, it's up to 10%. The reason that we would adopt such a type of cement, type GB, is to make the cement more sustainable, if you like, and that's because you're replacing part of GP. GP cement is of course produced from the process that requires you to get clinker, as I described in one of my videos. And this process is very energy intensive and results in a lot of carbon emissions. So to avoid some of these carbon emissions that are resulting from clinker, what we do is we replace the clinker with SCMs. And that's why you mix some of your GP with the SCM in accordance with the proportions that you see in front of you on the screen, and you get a more sustainable cement mix. Now let's look at the compressive strength and the differences that you see between GP and GB, so your general purpose versus your blended cement. GB typically would have a lower early strength compared to GP. However, GB would have a higher later strength. So that's sort of the main difference. Now, we talked about the general purpose cement. Let's talk about special purpose cement. So cements that you would adopt when you've got specific purposes. So there are four types that are discussed in the standards. In the Australian standards, we have type HE, that's high early strength cements. Type LH, that's the low heat cement. Type SR, that's the sulfate resisting cement. and that's cement that you would typically use, so for instance for your foundations. And then finally we have type SL, and that's where you want to limit the shrinkage that takes place in your concrete, and that's referred to as shrinkage limited cement. Having a look at the percentage of the 28-day compressive strength, where we compare GP and HE, you realize that early on, so we're talking about 0 to 3 days, the type HE, given that it's the high early strength type of cement, your concrete achieves the required strength quicker earlier on. However, in the long run, you notice that type GP is a bit higher. So common applications of HE cement would be where, for instance, you need to construct a building very quickly, a high-rise building, and hence you need to take off the formwork very quickly from your concrete elements. That's when you would desire a higher early strength at the very start. Now, green cements. It's a very important topic because, as you guys are aware, the process of producing cement is very energy intensive, and so instead of adopting, let's say, a particular, I'm giving an example over here, let's say 1,000 grams of clinker to produce a particular batch of cement, we replace, let's say, 20% of that, or maybe 10% with SCMs. So we're producing 90% clinker instead of the 100% originally, and we're replacing that 10% that's missing with SCMs. And what that does is, because we're utilizing a byproduct, so the SCMs are a byproduct of course, we're utilizing a byproduct, hence we're avoiding the disposal of these byproducts, so that's the first ecological advantage. Another ecological advantage is because we're not producing as much clinker as we used to before with green cements. Now we have a reduction in the carbon emissions that are associated with the cement production process. Apart from these ecological advantages, we have a number of structural advantages that are associated with green cements, and that's because of the addition of these SCMs and how it sort of plays a role in modifying certain properties, improving the structural behavior of your cement. Now, the performance parameters that all these cement types have to abide by according to the standards, these are listed in front of you on the screen. So the first parameter is the soundness of your cement type that you use in your concrete mix. You need to avoid excessive expansion. That's what soundness refers to in the standards. And you get expansion due to the hydration of the crystalline magnesia. And that's why the Australian standards specify that magnesia has to be present in your cement mix in a proportion that's less than 4% or 4.5% at a maximum. The second parameter is strength. So what's the minimum compressive strength? And compressive strength is sort of the measure of strength that we adopt for our concrete mix, and it's based on the cement type that we use. So different cement types would have different compressive strengths, or would lead to different compressive strengths in your concrete mix. The third performance parameter is your temperature rise, so the amount of temperature, the amount of heat, that's released during hydration. And we need to avoid excessive heat because that can lead to cracking. So there's specific requirements that are specified in the standards. The fourth parameter is drying shrinkage. So the standards, they try to limit drying shrinkage, and that's the loss of water in the capillaries of your concrete mix. And when that water evaporates, it can lead to cracking in the final product, which is something that we want to avoid from happening. So that's why there's a maximum movement limit that's specified for shrinkage. And then sulfate resistance, and that's associated with your foundations. So it's just to reduce sulfate attack that takes place beneath the ground. That's where your concrete foundations would be placed.